lesson, you are expected to identify outliers in one-dimensional data, describe the indication of anomalous behavior in one-dimensional data, and appreciate the use of these indications in anomaly detection and fraud. Our lesson about anomaly detection and fraud is actually getting more interesting, and in this session, what we're going to talk about is the outliers in one-dimensional data. So let me write here. And I believe as of this moment, I don't need to discuss to you what a dimensional data is. So when a one-dimensional data is a quantitative data, the question is, how do we analyze its distribution? So basically, what we do to analyze the distribution is we are going to compute for the statistics. This is the best way to analyze and describe the distribution of a quantitative data, right? So in this lesson, what we're going to have is a uniform distribution and a normal distribution. So we're going to have them one by one. So let's first have a uniform distribution. So a uniform distribution is actually characterized by its mean and standard deviation. So as you could see, the neighborhood of the data points are richly populated by some other points, just like any other point. The question is, how are we going to identify the anomalous points in this kind of distribution? Actually, when we talk about the uniform distribution, there is always a kind of argument when it comes to which one is really anomalous, because at first glance we could see that the distribution is somewhat equal, and as what we have said, the data points are somewhat distributed evenly, and there is almost an impossibility to think that there is really an anomaly in this kind of distribution. Actually, there is an anomaly in this kind of distribution. And what we're going to understand first is that we are going to know what is an indication of an anomaly in a uniform distribution. First is that we're going to examine the points. Okay, so as you could see that in some points in this plot, we could see that some points or some areas are more populated than other points. So as you could see, this part here is more dense than these parts of our data set, because the behavior in this part is somewhat different from other points. Then we could say that this part here, which is a small neighborhood, which is more populated than other parts of the data, then we could say that this one is exhibiting a very different behavior than the rest of the points. So because this is so, then this is suspected to be anomalous. But of course, in some cases when we have a situation like this, wherein the data points in most part of this neighborhood is very dense, and only in this part of the neighborhood is not dense, then we could also say that this one, which has fewer data points, is exhibiting a very different behavior in comparison to the rest of the data points. And with that, we could also say that this part is suspected to be anomalous. So that's how we do that for a uniform distribution. Now, we will go to a normal distribution. And now in this case, the situation is more exciting than the first one. And how is that? First of all, I'm sorry for my drawing, but let's just think that this one is really normal. The very basic understanding of a normal distribution is that the density of the points decreases substantially as we move from the mean. So this is our mean, for example, and as we could see, the points here and here are less in number in comparison to the points closer to the mean. So in this kind of distribution, the question here is, how do we define and identify the anomalous behavior? The way to identify the anomalous behavior for normal distribution is to zero in our threshold in its standard deviation. So how do we do that? So basically, what we do here is we divide this one into 3 standard deviations. 1, 2, 3. Okay, for example, here. And what we do here is that we set our threshold. And what is this threshold? Our threshold is a 3 standard deviation. So when the point is 3 standard deviation away from the mean, then it becomes a suspect for anomaly. So for example, we have in this case, we will just count 1, 2, and 3. For example, and the points going to the right that are beyond the 3 standard deviation are suspected to be anomalous. And the same situation also in the case of this part to the left. So these points, which are 3 standard deviations or more than 3 standard deviation away from the mean, are considered to be anomalous. What is this for? Why do we have to study this? When we have quantitative data, we usually analyze the statistics using distribution. With this distribution, we are able to understand the indications of anomalous behavior. We will be discussing more about these distributions in our future lessons. After all being said and done, let's try this. How do we describe the statistics of quantitative data? What is the indication of anomalous behavior of a uniform distribution? What is the indication of anomalous behavior of a normal distribution? Please write your answers in a comment down below so that we would be able to have a very rich interaction of ideas and that we can learn from each other. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.